Hello there, welcome to section 4 of Unit 3. And in this section, we will be looking at the constant volume gas and the absolute temperature scale. Let's look at the objective of this. At the end of this session, we should be able to describe the structure of constant volume gas thermometer, to explain the principle under which the constant volume gas thermometer works, and lastly, explain what an absolute temperature scale is. Let's look at the structure of constant volume gas. For starters, let's look at the parts here. There is a water bath or an environment to be measured here. That is our flask. And for this tube here, we have a constant gas inside here. We have also a scale here and a mercury here. So before we look, the physical change is the variation of pressure and of a fixed volume of gas. Before we go on, let's look at how this device is actually calibrated. Firstly, the gas tube here is immersed in an ice, which is going to cause a variation of this mercury reservoir here till the A reaches 0 and there is an increase or decrease in here. Secondly, we will immerse this gas tube too in a boiling water, which will cause a variation in the A point here to be 0, and also there will be a variation in here at 100 degrees. So that at the end, we will be able to plot a graph like by recording the value of pressure and the value of temperature as we have the mercury reservoir being raised and being go down. These two pressures and temperature values are then plotted as shown in this figure. The lines connecting to the 2 points serve as a calibration curve so that unknown temperature can be found in here. So in case you want to measure the temperature of a substance, we would place the gas flask in a thermal contact with the substance to be measured so that you have an adjustment of height in the reservoir B until the column reaches the expected or the temperature that it has measured. After that, we will use the value of the pressure, because right now it's pressure that we are measuring here. We will use the value of the pressure that we have to find out the temperature using this particular curve. So that in case we have pressure to be around here, we can just map it to our line that we've drawn here as our standard and mark it to the temperature, and we know the temperature of the substance to be measured. Let's look at absolute temperature scale. So if we use a constant volume gas thermometers filled with any different kinds of a gas or at any different pressures, we will still measure the same temperatures. That is why a constant volume gas thermometer is very useful. And an extrapolation of each of their graphs to 0 pressure occurs at the same temperature. That is 273.15. We can and will use this to create a new temperature scale. That is the absolute temperature scale. This common temperature at which all the constant volume gas thermometer converge is called the absolute 0. The size of the unit of this scale are the same as 1 on the Celsius temperature scale. The units are called kelvins and are indicated by a big K without a degree sign. This is also called a Kelvin temperature scale.